Adding sensors to your project is the first step to do something more meaningful with Arduino. So let's learn in this lesson how one can read the temperature data from very famous LM35 temperature sensor. Later on, we will print this temperature data on serial monitor of a computer at interval of every second. This sensor is very popular and can be easily available anywhere, so you can buy it very easily on any online retail shop. We can use this sensor in various projects such as power supplies, battery management, HVAC, and many appliances. Now, because this LM35 is an analog sensor, we need ADC pins on Arduino Uno, which can read analog voltage from this sensor. This voltage, output voltage, is linearly proportional to centigrade temperature. This chip on Arduino has in total 6 ADC analog to digital converter pins. These pins are ranging from A0 to A5 on your Arduino board. We will going to connect LM35 with A0 pin of Arduino Uno for this project. When we try to understand how to connect LM35 with Arduino, we must know the sensor has a 3 legs. If we hold sensor and keep flat surface towards us, we will find extreme left pin of LM35 is in VCC. The middle pin of LM35 is in data or the output pin, from where you will get the output data from the sensor, and extreme right pin of this LM35 will become in ground. Let's look at the final setup for this project. Red wire represent connection between plus 5 volt of Arduino to VCC pin of LM35. Yellow wire on the circuit schematic represents the connection between A0 pin of Arduino and the data or the output pin of LM35. In the end, we have a black wire which anyways will going to connect to the ground pin of Arduino and LM35. After setting up circuit, let's move towards the screen and start writing a code to make it work on a real hardware. Please make sure one thing: when you set up the hardware, make sure you don't interchange the pins or the connection between VCC and ground, because there will be the chance that you will going to fry your LM35 sensor. So just make sure when you connect, make sure 2 or 3 times before you power up the circuit. So let's go ahead to the screen and start writing a code. Let's start writing a code. What you can see on my screen is I have a setup function and I have a loop function. So this is a basic structure of the code from where we're going to start writing a code. So first thing first, because we are connecting LM35 temperature sensor, in order to read the temperature, we have to define a variable to hold the temperature data coming out of a sensor. So I would going to define a float variable and I will give it a name temp is equal to 0. Initialize this temp variable to become a float variable and the initial value will be 0. Then I come back to the setup function. I would going to write serial.begin and I have to give it the baud rate 9600 because I am using a serial UART function in order to print the temperature data on the serial monitor of my screen so that we can able to see what is the temperature that is coming out of the sensor. Then we come back to the loop function. There we have to do all the logic. So let's say temperature, the temperature variable is equal to, there is a built-in function in Arduino which is analog read. As we know that this LM35 is an analog sensor and we're going to connect this sensor to A0 pin of Arduino, so we have to say analog read. Which pin we want to read? A0, because that's where our sensor is connected to. And then we will say serial.println and then we just have to print the variable value, and we want to read this value after a delay of every second, so we're going to pass 1000 milliseconds. So this delay is another built-in function, built-in Arduino function, which takes the millisecond as a parameter, and after every 1 second, so 1000 milliseconds is a 1 second, that will print the temperature value. So let me upload the sketch before I'm going to make sure that the COM port is 12 and the board is Arduino Uno, right? So it looks okay now. So let me go ahead and click on this upload button in upper left corner. So as you can see on the lower left corner, done uploading. So we can open a serial monitor and see what is coming. So what we see is 59, which is not of course the temperature, because I'm right now into the city called Pune. It's in India, and it of course a warm, but of course not a 59 or 58, right? It's just a useless. The reason why we get this data, which is kind of irrelevant data at this moment, because what we read from this A0 pin where the sensor is connected is the ADC value. It's an ADC count, means we are getting the voltage from the temperature sensor and its equivalent ADC count. So as we know that we get a voltage on A0 pin from LM35 sensors, and we have to convert that voltage into the degree centigrade with the resolution that's been given to us into the data sheet. So the next job for us is to convert this value, this ADC counts, into a degree centigrade. So let me close this serial monitor, and we're going to write few lines of code. So to convert this ADC count into the temperature degree centigrade, I have to write temperature variable again, and I will say temp multiplied by, we have to write a value multiplying factor so that we can able to convert this ADC value into the degree centigrade. If you read a data sheet of LM35 sensor, then you will get to know that every 10 millivolt represent 1 degree centigrade, right? So we have to convert this ADC count, especially the millivolt that is coming on the onto the output pin of the LM35, into a degree centigrade. So to do that, I have to open up the calculator here. So let me open a calculator, and I have to do a little bit of maths for this. So let me go to standard calculator, and let's understand first the reference voltage that we are giving to LM35 is a 5 volts. So 5 divided by the ADC pin, that is A0 on Arduino, is having a 10-bit resolution, so it is 1024. So if you wonder where this 1024 comes from, then you might know, if it's a 10-bit, then 2 raised to 10 minus 1. Okay, 2 raised to 10 is 1024. So you divide 5, which is a reference voltage, divided by the resolution of the analog pin, that is 1024, is equal to, what we get is 0.004882. This is in voltage, right? So we have to convert this into millivolts. So I will multiply this with 1000, and what I get is 4.882812 blah blah blah, right? So this is a millivolt, right? But according to data sheet, if this is a 4.8828 is millivolt, then I have to divide this with a 10, because every 10 millivolt is 1 degree centigrade. So what I get is 0.488281 blah blah blah, whatever it is. So I will copy this by right click and copy this number, and then I have to paste this number in here, right? So we have to multiply basically what is coming from this A0 pin, okay, that stores in the temperature, and then temperature will multiply with this number, so that will convert this ADC value into this temperature in degree centigrade. Okay, so what we need to do here is we have to upload the sketch and see what comes now. So as you can see right now, done uploading. So let me open serial monitor and see what is coming. So now it's 29.30. So this makes a little more sense, that the temperature at my city Pune in India, it's now 29. It's quite a convincing. So so this is the temperature, right? If I hold this temperature sensor in my hand, you can able to see, if I squeeze the temperature sensor, you can see the temperature is increasing, right? It's a 30 and something more maybe in a couple of minutes. 31, perfect. So let me release the temperature sensor, and as you can see it's a 30, 31. Don't worry about this 132, 133 because the circuit little bit, you know, loose, so but that's okay. So let me close this serial monitor, and I want to make this program to look a little bit beautiful because right now it looks very ugly. So what I'm gonna do is I will take this I take the line number 10, and I would going to write serial dot print, and I have to send the string on serial monitor temperature, and then I have to print this number temperature value, and then definitely I have to do something more to give the final touch. So print ln, and then I want to say like star NC for degree centigrade, and I think this will look a little bit better. So this will read the temperature data after every second, and hopefully this will look a little bit beautiful or meaningful, right? So let me upload the sketch and see what happens. As you can see, done uploading once again. So let me open a serial monitor, and what you can see right now is a temperature value, and it looks a little bit better. Temperature is equal to this and degree centigrade. So let me hold the sensor, let me squeeze the sensor and see what happens. Okay, it's a 29, 30, perfect, 31, perfect, 39. Don't worry, the circuit is a little bit loose at my end, so that's why it's a little bit flipping, but in an all average it's 31 or something when I squeeze the sensor. Okay, it's a 32 now. Let me release the sensor and see what happens. So hopefully this temperature will drop it down. So right now I fixed the sensor, and you can see now the reading from the temperature sensor is very much stable, right? So slowly the temperature is coming down because I have released the sensor from my fingers. So I hope that now you have enjoyed this video, and so thank you very much for watching this video, and see you in the next video. Bye bye.